Hello students, I am Vaibhav Bajpayee. After successful IIT-JEE Advanced lecture series, I am coming up with IIT-JEE 2020 Advanced test paper discussion and analysis. So in this year, yesterday, in fact, paper was conducted, and this paper was conducted by IIT Delhi, and there were two papers, paper 1 and paper 2, and a total of 54 questions were asked in physics, chemistry, mathematics in paper 1, and with 18 questions in each subject, and similar number of questions were in paper 2. And in my observation, overall JEE Advanced 2020 paper was moderate to difficulty level. So now see section 1 of the paper 1, and in this section uh, there are 6 single correct questions, and for each correct question you will be getting plus 3 marks, and for negative where you are getting minus 1 mark, and if none of the options is chosen then your question is unanswered, that is you will be getting 0 mark. So first question is, let a comma b denote the distinct real root of quadratic equation x square plus 20x minus 20 equal to 0, and c comma d denote the distinct complex roots of quadratic polynomial x square minus 20x plus 20 equal to 0. Then the value of AC into A minus C plus AD into A minus D plus BC into B minus C plus BD into B minus D. So this question is actually similar to IIT-JEE 2011, and now what we do here, and this is easy type problem, and what we do here, we have to simplify this expression, and if you simplify the expression then we get AC into A minus C. So AC into A minus C plus AD into A minus D plus BC into B minus C plus BD into B minus D. So if you simplify this part, so we get A square C minus AC square plus A square D minus AD square plus B square C minus BC square plus BD square minus B square D. So we have to arrange positive terms together and negative terms together. So after arranging positive terms and negative terms, we get A square plus B square into C plus D minus C square plus D square into A plus D. And now we know that sum of roots equal to minus 20 and product of roots equal to minus 20 and C plus D equal to 20 and CD equal to 20. So we have to substitute the value, and if we substitute the value, so we get A square plus B square into 20 minus C square plus D square into minus 20. So it becomes 20 times A square plus B square plus C square plus D square. So we get 20 times A plus B square minus 20AB plus C plus D whole square minus twice AB, C plus D whole square minus twice CD. So after putting values A plus B and AB, we get 1600, 16,000. So 16,000 means we are getting D option. So in this question, option D is correct. Now, next, question number 2. Question number 2, and this is also easy category problem. And question is, if the function f such that r to r is defined by fx equal to modulus x into x minus sin x, then which of the following statement is true? If fx is 1 1 but not onto, fx is onto but not 1 1, fx is both 1 1 and onto, and fx is neither 1 1 nor onto. So first we'll check the nature of function, whether it is even or odd, or what is the nature of function at origin. So if we find f of x equal to modulus x into x minus sin x, and then x is replaced by minus x, so we get f of minus x equal to minus fx. So we get the given function fx is odd. So function is odd, then we have to plot the graph of function. Then we are getting an important point here, and the important point is the graph of function is symmetrical about origin. So that means if you plot the graph for x positive, so we have to take it symmetry about origin, and we'll get the similar curve. So now we have to plot the curve graph of fx for x positive. So for x positive, modulus x is replaced by x, so it becomes fx equal to x square minus sine x. And then we have to check the nature of function at infinity. So limit x tends to fx tends to plus infinity. Then we'll find out derivative of function, and derivative of function is coming x into 2 minus cos x minus sin x. So again we have to take a function gx, and given that g of 0 equal to 0, and now we have to check the nature of function in between 0 to pi. So if we check the nature of function in between 0 to pi, so g dash x is positive function, and g dash x is positive, and g of 0 equal to 0, then we say that gx is increasing function, and with the help of monotonicity we can conclude that gx is greater than 0. So if gx is positive, then what we say that the value of function at 0 is 0. So 0 per value 0 आ रही है, and for 0 positive, graph of function is increasing, and this graph will go to infinity, and for 0 negative, the graph of function is minus infinity, so this graph will go to minus infinity. So the range of function is real, and it is equal to codomain of function. So range equal to codomain set, then we get onto mapping, and the function fx is 1 1. So the answer of this question is fx is both 1 1 and onto. Now question number 3, and this is moderate to difficult problem, and the question is, let the function f such that r to r and g such that r to r be defined by f such that fx equal to e to the power x minus 1 minus e to the power minus modulus of x minus 1, and gx equal to 1 by 2 e to the power x minus 1 plus e to the power 1 minus x. Then area of the region in the first quadrant by the curve y equal to fx, y equal to gx, and x equal to 0 is. So we have 4 options. Now we have to define fx. So first we'll first we'll break this modulus. So for this modulus, let us take condition x greater than equal to 1. So if you take condition x greater than equal to 1, so now we get fx, and fx is e to the power x minus 1 minus, we get minus times x minus 1, so this will be 1 minus x. So fx equal to e to the power x minus 1 minus e to the power 1 minus x, and for x less than 1 it becomes 0. So this is fx. Now then we'll get gx, and gx is, this is the function gx, and we are observing that the function gx, graph of function gx is symmetric about x equal to 1 line. Why? Because g of x equal to g of 2 minus x, and g of x equal to g of 2 minus x, then this expression is replaced by 1 minus x, so we get g of 1 minus x equal to g of 1 plus x. So gx is symmetrical about x equal to 1 line, right? So now we get g of x equal to 1 by 2 e to the power 1 minus x plus e to the power 1 plus x. Then we'll find out the derivative of gx, and derivative of gx for x positive, x greater than 1 is positive. So we get gx graph is symmetrical about x equal to 1 line. So let us say that if we plot the graph of gx, so gx curve is symmetrical about x equal to 1 line, and this line is x equal to 1, and graph of function is defined like this. And then this function is constant, and this function is constant from x less than 1, and then it will go, and this function is increasing, and this point of intersection is 1 plus ln root 3, right? So we have to determine the area, and we have to determine this area bounded by this curve. correct? So now we are getting the same thing here. You have to determine this area. So first we have to write the area between 0 to 1. So 0 to 1 means we get this curve, and then area between 1 to 1 plus ln root 3, and 1 plus ln root 3 will be, and this is actually gx, this is gx, and this is fx. So we have to write gx minus fx, and we are getting a equal to 1 by 2, 0 to 1, e to the power 1 minus x plus e to the power x minus 1 dx, plus 1 to 1 plus ln root 3, 3 by 2, e to the power 1 minus x dx, minus 1 to 1 plus ln root 3, 1 by 2, into e to the power x minus 1 dx. And this is the final answer, and this is option number A, and option number A is correct, right? So this is also moderate to difficult problem. Next question is question number 4, and this is very simple question. Question is, let a comma b and lambda be positive real numbers. Suppose p is an end point of latest sectum of parabola y square equal to 4 lambda x, and suppose the ellipse x square upon a square plus y square upon b square equal to 1 passes through the point p. If the tangents to the parabola and ellipse at the point P are perpendicular to each other, then eccentricity of the ellipses. So we have to plot this parabola, and this is ellipse, and then this is point of intersection, and this point of intersection is, let us say that P, and the coordinate is lambda comma twice lambda. So we have to find the derivative at lambda comma twice lambda. So derivative to the parabola will be 1, slope is 1, and then we'll find out the derivative of ellipse, and this will be minus b square upon twice a square. So we have to write m1 equal to m2. So m1 equal to m2 means we get b square equal to twice a square. So actually b square equal to twice a square, so we are getting vertical ellipse. Right now we have to put the value of this result. We have to put the value of b square in this result because we are getting vertical ellipse. So for vertical ellipse, we have to write a square equal to b square into 1 minus e square, and put b square equal to twice a square. So a square and a square will get cut, and we are getting 1 minus e square equal to 1 by 2. So therefore e equal to 1 divided by root 2. So the answer is E. So this is very simple question. Now, in fact, in conic section we had done lot of good questions, right? So question number 5. Question number 5 is, let C1 and C2 be two biased coins such that the probabilities of getting head in single toss are 2 by 3 and 1 by 3 respectively. Suppose alpha is the number of heads that appears when C1 is tossed twice independently, and suppose beta is number of heads that appear when C2 is tossed twice independently. Then the probability that roots of quadratic equation x square minus alpha x plus beta equal to 0 are real and equal. Actually, equal to 0 are real and equal is. So there are 4 options. So for equal roots, we have to put delta 0. So delta 0 means alpha square equal to 4 beta, and alpha beta are integers because we are getting number of heads and number of tails. So that means alpha and beta will be integer. So only 2 pairs will satisfy. The first pair is if we put alpha equal to 0, beta equal to 0. Yeah, we put alpha equal to 2 and beta equal to 1. So alpha equal to 0 and beta equal to 0 means here I am talking about no heads, and we are talking about no heads in C1 and no heads in C2. So we have to use the binomial distribution, and for binomial distribution we are tossing coin twice and no head appears. So 2C naught into 2 by 3 whole power 0 and 1 by 3 whole power 2, and 2C naught 2 upon 3 whole power 2, because we have formula, and the formula is P of x equal to R, and that is NCR p to the power n p to the power r and q to the power n minus r. So suppose I am talking about no heads. So that means x equal to 0. So nc naught p to the power 0 and q to the power n minus 0. So now n is given 2. So we get 2c naught and p to the power 0 and q to the power 2. So we get 2c naught and p to the power 0 is 1, q is 1 upon 3 whole square. And then we'll get the p of x equal to 0 and p of y equal to 0. So similarly, we'll use the formula here, and this is for p of y equal to 0. So here we get the probability that will be 4 divided by 81. And now see the second possibility. And second possibility is when alpha equal to 2 and beta equal to 0. So p of x equal to 2 and y equal to, sorry, beta equal to 1. So y equal to 1. So now what is the meaning of x equal to 2? X equal to 2 means 2 head appears when we toss coin twice. So that means 2c2, 2 upon 3 whole square, and 1 head appear tossing 2 coins. So 2c1, 1 by 3 whole power 1 and 2 by 3 whole power 2 minus 1. So this value will be 16 upon 81. So now we get P of E equal to 4 divided by 81 plus 16 divided by 81. So if we add 4 upon 81 plus 16 upon 81, so this will be 20 divided by 81. Now see next question, and this is very moderate problem. And question is, so what is the answer of this question? Answer of this question is B. Question number 6. Sixth question is given. Consider all rectangles lying in the region x comma y belongs to R to R. X lies between closed interval 0 to pi by 2 and y lies between closed interval 0 to 2 sine 2x, and having one side on x-axis. The area of rectangle which has the maximum perimeter among all the rectangles. So what I did here, first I have to plot the graph of y equal to sine 2 sine 2x. So how will you plot the graph of function y equal to sine 2x, 2 sine 2x? So we have to use transformation, and first we have to plot y equal to sine x, then x is replaced by 2x, and we get y equal to sine 2x, and then we have to multiply it by 2 and it becomes y equal to 2 sine 2x. Understood? So what is the graph of sine curve? And if you see the graph of sine curve, so it is and this curve is, this is the graph of sine function. This is 0 and this point is pi by 2 and this point is pi. If x is replaced by 2x, sorry, this is pi and this is 2 pi. So if x is replaced by 2x, so divide all x coordinates by pi and all x coordinate by 2. So it is pi by 2 and this is 0. So in this question, the domain of function is given 0 to pi by 2. That means you have to take only this curve, and multiplied by 2 means the maximum value of function will be 2. So now here I have chosen this curve, and this is maximum value and this value is 2. So now let us choose a point alpha, and if you choose point alpha, so we are getting the coordinate alpha comma 2 sine alpha, and the value of alpha is same as this value. The value of alpha is 2 sine 2 alpha, and here we get 2 sine 2 beta. So height should be same. That means 2 sine 2 alpha equal to 2 sine 2 beta. So it means the graph of function is symmetric about this line. So it means this distance is alpha. So this distance is also alpha. And if it is alpha, so the remaining distance beta will be pi by 2 minus alpha. So now we have to put beta equal to pi by 2 minus alpha. So 2 beta equal to pi minus 2 alpha. So sine 2 beta equal to sine pi minus 2 alpha, and it is sine 2 alpha, right? So what is the perimeter? The perimeter means the perimeter, we have to write this length. This is beta minus alpha. So beta minus alpha twice. Then we have to write this length, and this is 2 sine alpha, and this is also 2 sine 2 beta. So 2 sine 2 beta is same as 2 sine 2 alpha, so it becomes 4 sine 2 alpha. And now we have to differentiate this expression. So if you differentiate this expression and put dp upon d alpha equal to 0, so we get cos 2 alpha equal to 1 by 2, and therefore we get 2 alpha equal to pi by 3 and alpha equal to pi by 6. And again we have to differentiate, and we get minus 16 sine 2 alpha, and at pi upon 6 this quantity becomes negative. So here we say that perimeter is maximum when alpha equal to pi by 6. Then we have to find its area, and area of rectangle is beta minus alpha into 2 sine 2 alpha. So beta is pi upon 2 minus alpha. So we have to substitute the value of alpha here, pi by 3. So we get pi divided by 2 root 3, and this is the answer, right?